well, we could start with Einstein's Arrogance.
Yes.
And this is in a nutshell, the post where basically when Einstein was asked, hey, if Eddington's observations that he's going to go do during an eclipse don't demonstrate the predictions of your experiment, what do you have to say? And he's like, oh, well, I feel bad for Sir Eddington because my theory is right.
No. It's better than that. Since Eddington was going to be measuring eclipses to try to confirm the theory of relativity, when he was asked if the observations failed to match his theory, Einstein says, I would feel sorry for the good Lord because the theory is correct. Oh, wait, because he was Lord Eddington. Man, I thought that he was saying he would feel sorry for God.
That would be another level of arrogance that would be beautiful. Well, I feel sorry for God that he set up the wrong universe because my model is metaphysically correct.
That's what I was thinking, that he was like, I'm sorry God screwed up the eclipse, man.
That's delightful. Yeah, that would be one more, another rung on the arrogance ladder. That said, he was right. So one Lord was wrong, at least one. But Lord Eddington wasn't trying to disprove him, but he was just trying to test it. So that's the question. Sorry, go ahead, Jace.
I just was remembering, wasn't it Einstein that said God doesn't play dice?
Yes.
At least I remember it being attributed to him, even though I have the flag that whenever anything gets attributed to Einstein, I'm not supposed to.
Oh, that's true.
That.
I know Stephen Hawking repeated that attribution in at least one of his books. So if Hawking believed it, then
I had to reread the original papers to be sure Einstein had even come up with relativity. So much gets attributed to this guy.
He suddenly feels much less arrogant to me because, like, just disagreeing with somebody else's empirical data, maybe they wrote it down wrong, maybe their observations were incorrect. Like, I thought. When it says Einstein's Arrogance at the top of the post, I was like, that is hubris, Like, that is the sort of arrogance I was thinking.
I want to add one other observation I see from the post, which is that the sentence is, a journalist asked Einstein what he'd do. And I'm like, I can imagine, in fact, being slightly more arrogant than usual towards journalists. I don't know. They're often very critical.
They just the journalist twisted the quote to make it sound more headline-y.
Yeah.
I feel really sorry for Einstein if he had to deal with the level of press that, like...
Yeah, my guess it was slightly less bad at the time.
I don't know. They, had yellow journalism back then, which...
Oh, yeah, that's true.
I think that's basically the same thing we have nowadays, just with a different name.
What was yellow journalism?
It's the same thing where people greatly distorted the facts and would say things that were, in some cases, just blatantly untrue in order to push their own agendas.
Scientists baffled.
Interesting.
Was Einstein wrong?
Yeah.
Still see that one all the time.
So moving through this one real quick, the gist is, so since he's not in fact saying that the Lord himself is wrong, he's challenging Lord Eddington, or he's challenging the possible outcome of the experiment failing to prove relativity, or to demonstrate it rather. So the question is, is he being super arrogant by saying that? And I guess in a sentence, to summarize, not really. Like, the fact that he had postulated the theory of general relativity at this point and demonstrated it mathematically, that is more than him just saying, that already has so much weight behind it than it does if it was just him guessing on a dice roll or something, right?
Yeah, the amount of bits of evidence it required to pull these particular equations out of the space of all equations, there was an immense amount of evidence already pinning down what the possible outcomes could be. To have done this far, he must already have had, and given that he was correct, he must have already had an immense amount of evidence suggesting this thing, to the point where he felt confident that if someone said empirically it didn't come out, that they had messed up with their empirical tests.
This post ties very well with the previous one, how much evidence is necessary, because that one specifically talked about bits of evidence, which we kind of skimmed over because it was more technical and we don't have, written format. But he does say that to assign a 50%, Eliezer in this case says, to assign a more than 50% probability to a correct candidate from a pool of more than 100 million possible hypotheses, you need at least 27 bits of evidence. And then says that just coming up with what was it? how likely is it that Einstein would have exactly enough observational evidence to raise general relativity to the level of his attention, but only justify 55% probability? And it was like 27.3 bits. And he was like, how likely is it that he had 27.3 bits of information rather than 28 or 29? He was probably pretty damn sure that it was true from all the info that he did have.
Anyone else have anything on this one?
I have one unrelated thing, but I do want to. I wonder if Ollie wants to say anything. We were chatting a bit about Einstein's general reasoning methods being also kind of surprising at the time. Like, it was somewhat controversial the way he came to his physical theories. It wasn't like each step of it was pinned down by evidence. He did a lot of sort of reasoning from his intuition and building up sort of mental models, which was also kind of interesting. As I think that was sort of controversial at the time as a way of doing physics.
Yeah, there's just. I guess there's like two interesting directions that I can imagine going with this post. Well, one of is like the question of, okay, but why does like traditional rationality, as Eliezer calls it, or just like kind of like traditional science, have this norm of like that kind of being bad form? And number two is like, I think it's very interesting to like think about what kind of mind Einstein had that like caused him to be like arrogant in this way, if we want to like call it arrogance. I generally like, I mean, of course, Einstein as like discoverer of like two biggest paradigm shifts in like physics of the last century. Is like, I always find him a very, very central, like kind of like data point in when I'm trying to figure out how good reasoning is supposed to work, which I guess is a bit, of course, like everyone tries to do that, but I still find it very interesting.
I've had a book since I was a teenager that my sister got me, and I haven't actually read it, but it's downstairs, called How to Think Like Einstein.
Nice.
So you've reminded me that that book exists. I will read that and get back to you if I actually learn how to think like Einstein.
Great.
I think this post is a very interesting contrast between how humans think and how perfect Bayesian reasoners think. And I think like Eliezer actually had a point to doing that. I don't know, maybe I'm wrong, but he does point out in this that if you have like enough evidence to find this hypothesis in hypothesis space, that you need like a huge amount, like you said, 27 bits. From a Bayesian perspective, you need an amount of evidence roughly equivalent to the complexity of the hypothesis just to locate the hypothesis in theory space. If there's 100 million alternatives, you need at least 27 bits of evidence just to focus your attention uniquely on the correct answer. So, like, for a Bayesian reasoner, you need a lot of evidence, and so you would be really sure that once your attention has been drawn to one particular hypothesis out of several 100 million, that you got the right one. But, like, I don't think humans necessarily work that way. Like,
yeah, at the end.
Yeah,
since the human brain's not a perfectly efficient processor of information, Einstein probably had overwhelmingly more evidence than would in principle be required for a perfect Bayesian to assign massive confidence to general relativity. And he just didn't even use a number there. So just a lot.
He does say that. I'm not sure. I don't know. Because I think humans cut out a lot of steps and will give probabilities too high of a weight if they, if it is convenient for them. And I don't think any human would really consider 100 million possible hypotheses. They already start with a vastly curtailed hypothesis space. So I don't think a human.
I think an average human, yeah. But this is Einstein. He might have had a real lot of evidence.
For allowed to put anybody on a pedestal, it's Einstein.
I mean, I think the key difference that kind of comes through in the post is that it just matters really drastically. Like, your perspective really matters a lot. Like, I don't think it is bad for someone to ask Einstein to provide more evidence if they are not convinced. Because, of course, like, they don't have those bits of evidence. And I think there's kind of this, I find this part of, when I think about how science works, I find it very interesting that, like, in particular in substantial parts of modern science, it's like very hard to have your internal credences diverge very much from what you think your public credences are. Where, like, it's very hard to be like, I am 99.99% certain of this, but, like, I think you should only be 30% certain on this. This is, like, a very, like, complicated mental operation and, like, verbally very hard to get around, where usually, like, when I say that, like, this is 99% likely, I'm kind of asserting that you are also supposed to believe it is 99% likely. And, like, then if the other person is like, what? I don't think it's 99% likely. We don't actually have a lot of, like, very elegant scripts to be like, oh, I think I have the relevant evidence, even though you do not. And I think a way in which like science has dealt with this is kind of to make it so that like when you assert confidence into something, you kind of assert the confidence that is known for the complete audience that you're like that is kind of like achievable via consensus of the scientific community or the full audience you're talking to or something like that.
Oh, okay.
So when you say that something's 99% likely, I think what it usually gets translated to is we have a set of evidence that we can all agree on that like makes this hypothesis 99% likely, which is of course a drastically different statement than saying I think I have evidence that makes this 99% likely. And I've recently been thinking about this where I was just walking home yesterday and I was mentally, I don't remember how I got into that, but I was mentally analyzing my internal affect for how I would react to a bunch of sentences prefixed with I think versus not I think, and how drastically those changed my my affect towards them. Like I was like,
in what way?
So
I think sounds so much less confident. Like it's weird because if someone says I believe, if you're talking to and I don't want to put words in your mouth, but for myself, like if I'm talking to Inyash and he says I believe this, I'm like, oh, okay, he's really sure about that. If I'm talking to I don't know, like my mom, and she says I believe this happened, like that sounds way less sure than if she just said this happened. Like it's so like if someone says oh I think this is it rather than this is it, to me it like cuts my confidence in what they're saying, and I think they're trying to communicate the confidence in what they're saying. Like it just cuts it way down.
I remember when I first started writing, I was still in the habit of speaking kind of like a rationalist, and that actually makes for terrible writing because we often couch things with I think, I believe, and this stuff. And the first thing you got to do is get rid of all that, unless you're specifically writing a character who is in dialogue demonstrating that they're unsure.
Yeah.
Didn't you want all of this important epistemic information about my epistemic state? No, I just wanted to know what you were thinking about today. Oh, my sentences were so much more accurate before you asked me this.
So I do think it's not. Sorry, go ahead, Trace.
Just sort of an aside, but there's this book that is about a girl with OCD, and I really related to this. It's one of my childhood books because I also had OCD, and it's the first time I ever actually saw it portrayed. And one of the things that she does is when journaling, she realized that I can't ever be sure that something is true. So she would start every sentence with, I think. And then this became a ritual where she would write just a bunch of I think at the top of the page. But then that didn't feel good enough. So she like took the words I think and made them into a symbol and then would draw the symbol repeatedly around the page.
Oh,
wow.
Just to really, really make sure that she wasn't claiming to know something that she maybe didn't know. And it would be things like, I think I went to school today. I think my mom said this.
That's great.
There's a lot of interesting neurological stuff from that. But anyway, onward.
Real quick, what was the book called?
It's called Growing Any Way Up.
Okay, in case anyone wants to read it.
Yeah, it's like a YA book, but recommended. It's really, I thought it was really interesting.
Nice.
Yeah.
Yeah.
Going back to one of the other points that we were talking about, I think it is important for like healthy communities that are either intellectual or scientific communities, or even like building communities that like try and build useful things like startups. This is an important point to realize that people can have a lot of evidence that you do not have, and they can be much more confident in a thing than you can be, and not have norms where this is like inappropriate or something. I think it's often the case that small teams of startups have like interviewed like hundreds of users and understood, like built a pretty accurate model of what problems they're facing, and has like tested trying to fix a little bit and making a prediction about how it would go, and just being validated to the point where they just have overwhelming evidence that there is like a product here that a lot of people sort of want to use. And then they're very confident in their business, which from the outside, I think people often call it kind of overconfidence. Whereas I think you can just, in fact, similar to Einstein here, although not by exactly the same methodology, reach quite a high level, like get quite a lot of evidence about a thing, but not in a way that is like easily communicable in like a short conversation or something.
Yeah, like I find it interesting about the I think distinction. There's this, like, I think English was just like, well, it kind of communicates a different level of credence. But I find it very interesting that I think actually, even when you explicitly include the credence, my internal reaction to it is still drastically different. Where, like, the statement like, that's at most 50% likely, versus the statement, I think that's at most 50% likely, feel drastically different to me. Where the
Yeah.
first one is like, if you come to me in a conversation and say that's at most 50% likely, that sounds to me like you're asserting that we both are supposed to know that it's at most 50% likely. The second one says, this is my belief, this is what I think.
I do observe when you said that. My internal responses to the person who said, "I think that's 50% likely." I was like, I had some impulse to like ask about how they were viewing the thing and like get a better understanding of their perspective or share a bit more of mine. And the person who said, "That's no more than 50% likely," I just wanted to offer them a bet.
I can't help but, well, I was going to digress a bit with the annoyance of trying to get some people to agree to bets, but I find that people who aren't raised with or who aren't raised necessarily, but who haven't adopted the like mentality of sticking your neck out to defend a belief, if you offer them, like, I'll just give the brief story. My manager was, for some reason, brought it up like twice in a week. He wanted to say like there might be some legitimacy to the false election claims going on, and we should really just sit and, none of us have all the evidence. I think it's putting words, paraphrasing. I think it's epistemically humble of us to just kind of, wait for the information to come in. And I was like, I tell you what, I'll bet you $500 tier 50 that it comes out this way. And his response, "Oh, I don't bet. I'm not a gambling person." And I'm like, you don't want $500? Like, then,
Yeah.
I mean, come on.
This has been one of the benefits of having prediction markets is that all of my housemates and friends have just been making money off.
Oh yeah, it's been so insane. I'm so confused. I have so many thoughts on this.
So have you seen? Yeah, I mean, you've seen there's
I have
been a bunch of
questions.
prediction markets still sticking like until I think the last couple of days, but still for like a whole month after the election, put it at like 12% that Trump is still the president. And so I think just a bunch of my friends have put in a couple $1,000s into all the different prediction markets and just been making money. Which is
I
very
want to learn how to
weird.
do that.
Isn't
Sort
that
of.
technically not legal?
No, there's some legal prediction markets. So predicted is legal, and there's one other one that's legal in the US.
Okay, that's what had been stopping me because I kept hearing that betting on election results is completely illegal in any way.
Nope, definitely predicted has a specific. So I have looked into this a good amount because one of our good friends, Jacob, who like currently is collaborating a bit with LessWrong, has a. He has for a while been trying to get SFTC.
No action letter.
Yeah, and no action letter from the FTC, whatever the thing is that's supposed to like limit like betting and various currency related things in the US. A letter that like is the thing that Predicted got that allows him to run a betting market on various interesting things. And so I've read a good amount about all the regulations in the space because I've been thinking
Kinds of
through things.
things.
Okay, that is
that
is a good update to have.
Really.
But sorry, Jace, I think you were going to ask a question.
I was curious what things he wanted to include as things you could bet on, but also realized that we maybe should like get through the first sequence.
Fair enough. I'll hold this up for one more second. What was the name of that website? You said Predicted?
Predicted, yes.
Predict
Just-
it.
Oh, Predict It. Gotcha.
Exactly.
All right. Well, I need to start making some money, so I'm going to bookmark that for now.
Can I hit one last thing on this post before we move on?
No. Of course.
That was not an answer I was expecting. It reminds me of the time we met with Robin Hanson. Remember, he came out to dinner, and like the third time I started a topic with him. Hey, can I ask you something? He was like, "You can stop asking me that because you always can. That's why I'm here." Like he said it really nice, but I was like, "Oh man." Yeah, it was a verbal tick of mine when it's like someone I really respect. I'm like, "Oh, I don't want to use your time. Can I ask you this thing?" But no, the thing is, there's a post later on which always never quite sat right with me, where Eliezer says that a very powerful true Bayesian predictor could come up with the theory of relativity watching just 3 frames of a video of, I believe, a water droplet falling on and bending a blade of grass. And he said if it was powerful enough, it might be able to do it with just 2 frames. And like that always seemed really ridiculous to me. But reading this, especially at the end, when he says that since the human brain is not a perfectly efficient processor, Einstein probably had overwhelmingly more evidence than he would need in principle. Like maybe the more I think about it, the more like maybe in 3 frames of video, you can get 27 bits of information. And if you were a obscenely powerful Bayesian predictor processor, maybe you could get general relativity out of that. And that's what he was setting up with this post on Einstein's arrogance.
Yeah, that thought experiment is one that I've actually been thinking about for like basically the last decade, just like at least once a month or so. It's been like one of the big ones. And I've had so many disagreements with lots of people I respect on it who think that the number is much, much, much higher. And even like I think I had at one point a disagreement with Luke Milhauser, where he thought that it was pretty likely that maybe not a perfect Bayesian predictor, but at least anything we're going to get in the form of AGI or something to that, still probably will have to run experiments in order to like figure out the right like model, like at least extending beyond relativity or something. And I still think that's wrong, but it's like definitely I've talked to many people I respect who disagree with kind of that free frame number, at least in the AGI case, quite a bit.
It feels absurdly low to me, but I am no longer at the point where I think it's obviously wrong. Like, it could maybe be possible.
It reminds me of, I think the guy's name is Douglas Hubbard, who wrote How to Measure Anything, which is a cool book I read as a teenager. And it's there's one example in that which always stood out to me, which was people often talk about how you need more data and lots of data before you can like feel very confident about a hypothesis. And he was sort of counterintuitively making the claim that like the first data point is most of the information you need. And his example was about guessing the weight of jelly babies. And if you went to someone like me, for example...
What are jelly babies?
Or sorry, jelly beans? I can't remember.
Babies. I'm really reminded of Free Worlds Collide. Oh, God.
It's like a jelly embryo, really. It's a baby at 4 days of gestation.
Do you guys not have jelly babies? Is it just a British thing?
Well, they look more like beans than babies to us, or to me anyway.
Oh, no, you make them little bears or something. Anyway.
We have gummy bears.
Okay, well, ours are a bit...
They actually
I'm
shape
not
their
going into the
baby.
exact phenomenology of the sweet.
I really want to go to Britain and just
I
see
need to
people
get these
eating jelly
imported.
embryos.
Oh, God. Yeah, sometimes this is horrible. Sometimes our housemates just like, I think Daniel Phelan, who's from Australia, does this particularly much, where he just asserts that something is completely normal in Australia. That, of course, isn't.
And he's
When
just
I've heard
making
about Australia, I would just believe it regardless of what it is.
Yeah.
Isn't there an Australian saying that started out that way? That's like, I didn't come here to wrestle spiders or something?
And have sex with snakes? I can't quite recall how it ends. All right, I'm going to go with jelly beans. So you're like, what is the weight of a jelly bean? And if you're like me, who has not done much cooking for myself, I don't really know how much things weigh. Or I certainly didn't when I was reading the book. And you're like, is it 20 grams? Is it 2 grams? Is it 200 grams? Is it 0.2 grams? I don't know the right order of magnitude for this sort of thing. And then if I give you the first jelly bean and you're like, this is 15 grams. You're like, I think I have a pretty good guess of what the next one might be. I've zoomed in on roughly what order of magnitude I guess. And maybe you gave me like a weird one that was like a broken piece of it and you're a bit wrong or something. But I think often the first data point can orient you just what like order of magnitude, what ontology are we even talking about? And so I have some sense that like I've not really lived in any other like physical universes, and I don't really have much intuition about what could exist. But if I had thought about what sort of physical universes could exist or something, and like what the space of physics is, and then you just show me a thing falling, I can imagine going, oh, we're in that kind of universe, the sort where the things are attracted to each other with this sort of rough, like, I can see the size of the thing the water droplet fell to, I can see the size of the water droplet, I can see the way it like bent over one frame, which tells me a bit about the fluid mechanics. I can see, I can see that there is like things of a certain level. I can see what level of organization we're on with like how many levels of atoms or something are going on. And so I don't feel confident either way about how surprised I could feel for the first time watching the physics of the universe play out, and therefore how much I could update on it. So I don't have a strong opinion, but I don't feel confident that it's not 2 or 3 frames.
That's a damn good point. If you don't even know what sort of universe you're in, those initial frames are going to give you a huge amount of info.
Yeah, and I just don't know how much, because I don't know. I didn't have a prior coming into this universe very much.
Yeah, I don't know how many self-consistent theories of physics there are that are like close by 2 hours. Like, it's plausible that there just aren't that many, and it's like, well, if you actually write down, like, of course there are infinitely many, but if you like actually like try to like order them by complexity, and you're like, well, I don't know, like they're only like there's a bunch of ones, like the only self-consistent universes that like can support life actually have like one of these, like maybe 100,000 options, and just like this one really looks like it's one of these.
All right, well, shall we move on?
Move on.
Occam's razor.
Oh, I did want to add one thing in about predicted. Sorry, I just didn't want to give people bad investing advice. I think you should Google a couple of posts on LessWrong. I think there was even one in the last year about predicted, because the main thing that goes wrong is you can often look at a predicted prediction and think that's wrong, but the issue is there's a lot of transaction fees, such that if you were to try and make money on the very small margins or something, they would actually charge you more money for trying to make the transaction, such that it would not be worth it. So there's some difficulties there. So don't just, if you see a prediction that's a little bit off, don't immediately expect you can make money. I would look into it a bit more.
I saw one that the top one here under U.S. presidential election is that 95 cent is has the Democratic Party winning the presidential seat. I'm imagining that there's more than a nickel on the dollar for transaction fees, unless you're probably betting a lot, right?
So the problem is you can't bet a lot. That's the thing that makes predicted legal, is that the bets are capped per person at, I think, something like $500, something between $500 and $5,000 of stakes.
To me, that's a lot.
Yeah,
Oh yeah, you couldn't bet several figures of income on it. But yeah, I get what you're saying.
Is that per bet or like per month?
I think it's like your total stake you're allowed to have in a market, like how much money you're allowed to have tied up.
Oh, okay, yeah. And if you're like making 5-6% margin, that's not nearly enough to live on.
Yeah. All right, that was my point about predicted. Should we talk about the next sequences for another 50 minutes and then wrap up the podcast?
No, that's great.
Thanks for clarifying that, actually. That's good information.
Yeah.
And then Occam's razor. Are we ready for Occam's razor?
Yeah, let's do it. So, go ahead.
Oh, yeah, no, you do it.
Oh, okay. Well, I was going to say just a real quick recap of Occam's razor. I'm assuming everyone already knows what it is, but for anyone who may have missed it, it is the heuristic that the simplest explanation is usually the correct one and the one that you should go with. I believe formally it stated something like one should not multiply entities unnecessarily or something.
Yeah, that's what I remember.
Yeah.
Okay. And in the post, Eliezer says that the more complex an explanation is, the more evidence you need just to find it in belief space, is kind of his version of that. And he said that Occam's razor is often phrased as the simplest explanation that fits the facts, is the definition of Occam's razor. And Robert Heinlein replied that the simplest explanation is, the lady down the street is a witch, she did it. Which, on the face of it, seems to be the simplest maybe, but it hides a lot of complexity within the sentence that we just don't think about, because there's a lot of labels in that sentence that have stored complexity in them. He pointed it out that we could shorten the entire sentence just to a sequence of a few letters and say, look, it's even shorter. Does that reduce the complexity? And no, it doesn't, because the audience already has to know what those few letters stand for. And in similar way, like which itself is a label for a lot of extraordinary assertions. So just because we know about a concept, that doesn't mean it's actually simple. And in fact, the human brain is the most complex artifact in the known universe. So positing a human brain as an explanation for something already has a lot of complexity built into the answer.
Mm-hmm.
Yeah, I've definitely, I was confused about that post for a while, and I made some confused questions on LessWrong, 3 or 4 years about it. Because I think the post really asserts two very different things. And I totally got them mixed up at some point. Where the first thing that it asserts is that many concepts that humans think of as simple aren't really simple. And I think that's a point that's actually pretty hard to make. That requires a bunch more additional justification that totally the post doesn't do. And then it makes a second point that's completely separate from that, which is that an explanation needs to actually reduce the complexity of the remaining data, which is something like, if you want to give me an explanation, after I have, you have given me the lady down the street is a witch, she did it. The thing that the totally separate point he's making is that, that doesn't tell me that the sequence doesn't come out like A, B, C, D, E. I still have to say that, because actually having heard the first half of the sentence of the lady down the street did it, doesn't actually help me at all predicting the sequence. It gives me zero Bayesian evidence about the sequence.
Yeah, you're right. There should really be 2 posts.
And I think the first one is actually kind of hard, because there's this really real objection to the flavor of Occam's razor that Eliezer is proposing here, that like usually goes technically under the name Solomonov induction, where you have this giant free variable that's the choice of universal Turing machine. And he talks a bit in a post about like, well, you can choose a universal Turing machine however he wants, but I've actually found it like a pretty hard to wrap your mind around, because just like there's nothing in the laws of physics and nothing in the laws of reasoning that we know of that means that we can't use like witches as fundamental units in our programming language. Like I can totally write you a programming language that like I choose as my universal Turing machine that has like simulate a like universe with a single witch in it in an empty white room. That's like it's a primitive at the same level. Like let's say instead of we have Python and we have Python plus, and Python plus is all of Python except it has the witch command, which allows me to type in witch open parenthesis sentence, and then what the witch command outputs is a string that is whatever the witch responds after I simulate her in a like large, like infinitely large white universe with a booming voice speaking down the string that I input into that voice, into that void. And that's like a language that is like I can use that as my universal Turing machine. And now suddenly witch is a fundamental concept. And now we need to argue for some reason that is inelegant, that is wrong, that sounds like a really weird choice, a fundamental entity in my programming language. But those are all arguments that have to be additionally made.
I don't know. I don't think I could agree with that because, I mean, maybe he should have made a post about what a Turing machine is, but like a Turing machine is the simplest possible way that information can be processed in concept. Like you would have to have some way to simulate a witch first, and to do that you would need something equivalent of a Turing machine because information would have to be processed to simulate anyone, right?
So the like a Turing, like when you think of universal Turing machines, usually what like the key question is what is the ontology of the thing that you are describing, like of the language you're writing in. I do really think it's very useful to just think of programming language as Turing machines. Like that's like I find that much simpler to think about as opposed to the weird thing that Turing wrote down, which is like this weird like robot that like slides on a tape to the left and right. And we know that every universal Turing machine can be modeled as a simple programming language, and that every programming language can be modeled as a universal Turing machine with an appropriate translator at the beginning of it.
But a Turing machine at its simplest is just a way of storing information and then doing things to that operation, doing operations to that information to change it into a different type of information.
Correct.
Like you can't really have any simpler form of information processing, right?
I think that seems right.
Correct.
I think, by the way, I am totally confused about it. I was like, oh, Occam's razor. I notice I feel really philosophically confused about it. And then we talked about it for 5 minutes, and I feel basically as bad. Certainly, I think with a Turing machine, you can in principle run, I think, the very costly computation that Ali was describing, where you could, with enough space, you could simulate or emulate or compute what would happen. You like specify the physics, and you specify that there is like a witch in this void, and then you like output some translation from whatever the like physical vibrations are in the universe to a set of ones and zeros, and have that be a part of the output of the Turing machine.
Oh, absolutely.
I think for me that the idea of having like a witch function and then calling that simple, like the meat of the witch function, you know, you go in to define it, like all of that's going to be enormously complex, right? And so I
more
think
complicated a program than I have ever written.
No,
Right.
like the problem is in that moment you're begging the question. When you say that it is enormously complex, what concept of complexity are you using to assert that?
Oh, nice. Good point.
Complexity that is grounded on the idea that you already have some programming language in mind that measures the complexity of that hypothesis. But the whole point of Solomonov induction is that, well, you need to first choose a programming language in which you measure complexity. And so there's a separate thing of just like elegance where, well, like it's kind of like humans have some shared intuitions of elegance, and that points towards some natural choice of universal Turing machine that makes stuff like, well, we're just going to like have a witch function sound really dumb. But I think now we need to argue from that intuition as opposed to arguing from some kind of mathematical truth.
I see what you're saying. Yeah, I guess what I meant is that the witch function wouldn't be brief in what it did. So I don't know if that's the exact same thing as not complex, but I can't imagine the model of this of the witch function being like, you know what I'm saying, brief. It's not going to be like adding two numbers or rolling a die. I guess it depends on what the which function does. If all the which function does is within what bounds, right?
Yeah.
Does it turn random villagers into newts, or does it just is it just lighter than a duck? Like that, if it was just weighs less than a duck, then that witch would be super easy, right?
So
Yeah,
I find it actually.
I have a hard time imagining, and perhaps this is like the root of where my intuition comes from, that some things are simpler. I have a hard time imagining creating a programming language where it was simpler to simulate a witch in the universe and chat with her and get her output versus, writing some if statements. I feel like both in terms of like the programming language and the like hardware, like the actual amount of hardware I would need to compute one of them versus the other seems
kind of. I actually think modern neural nets provide like a really useful intuition pump here. Now that like more people are familiar with them, like neural nets are kind of this archetypical example of, in the space of like neural net programming languages, it's actually kind of hard to end up with one that's just like really good at reliably adding numbers. It's like,
I get what you're saying, but like the biological neural nets that we were familiar with before DeepMind were human brains, which, as stated, were one of the most complex artifacts in existence. And like the computer neural nets we have nowadays are not simple either. They take,
massive amounts.
Yes, I don't even know the correct order of number to say how many bits they use up, and they are not understandable by us due to how complex they are. They're simply much more complex than the laws of physics, for example, which can be encoded in surprisingly few bits.
Well, no, like that's the statement can be encoded in X number of bits does not have any mathematical meaning if you don't specify a programming language in which you're counting the number of bits. So you can't say that the laws of the universe are generally encodable in such a small number of bits. You need to say generally encodable in a small number of bits in this programming language.
Well, I think that's why he brings up the universal Turing machine, because that one has simply, bits of 0 and 1 on off that can be manipulated into,
But
states.
there's an infinite number of universal Turing machines, all of which will use different ways of like will have different description lengths. And the core insight is that you can write a translator between any of them. You can write a translator between any programming language that is Turing complete and any other one. And a Turing complete programming language will have an associated universal Turing machine. But of course, the space here is infinitely large. There isn't just like one universal Turing machine that is handed down to you. There's an infinite class, and Python, which has the which function, is an element of the unit class of universal Turing machines. It's just like you can grab a universal Turing machine, and there's the one that has the which function.
I guess I don't get. I feel like I feel somewhat compelled by the idea that in general, it is not clear to me which Turing machines will be simple to compute in my universe. I do nonetheless feel like my experience of my universe, I don't know about yours, is that a couple of if statements and a couple of loops can be run with far less physical matter.
Correct. And I think that's a really interesting inference to make. But it also has a really weird amount of circularity, where like you're trying to use Solomonov induction to determine what the physical rules of your universe are, and then you're trying to use your model of the physical rules of the universe in which you're in order to determine which choice of universal Turing machine is the right one for Solomonov induction. And you're like, well, is that valid or not? My current answer is, I don't know. I feel confused about this.
It does get pretty circular.
Yeah, it's interesting. It reminds me of Abram Dempsey's got a great post on LessWrong that I think came out this year called An Orthodox Case Against Utility Functions, where he does make a case that a lot of the way we standardly think about utility functions and so on is from the perspective of the universe. Like you have all of these different like laws of physics and arrangements of matter, and we have a function from them to states of utility. And he offers a quite different model where, which is from the point of view of somewhere or someone who is like part of a universe where they don't really understand the rules, and they're like gradually splitting up their world model into different high-level chunks. And I don't fully grok it, and potentially Ollie will grok it better than I do. But it's something that I think tries to grapple with this question of some of this circularity of trying to say, I didn't come into the universe knowing which universe I was in, and therefore I didn't know which sorts of program languages were simple to run in this universe. And as I've explored it a bit more, I have come to that sort of conclusion, and I have fed that back into my expectation of which further hypotheses are simple versus complex.
Yeah. The other thing that I think is really important to point out epistemologically about the Occam's razor post is the fact that, like, I actually am not that sold on the complexity prior on its own. Like, the obvious other prior that you might want to have is the speed prior. Like, when you run a Turing machine or just a program, there are, like, two major facts about a program. Number one is, like, how long it is, and number two is how much compute resources does it take. And in a bunch of places in the sequences, Eliezer basically asserts that, well, just the length of the program matters. But he doesn't actually argue for it very well. I think it's totally reasonable to be like, well, I want my programs, I like assign higher probability to the programs that like both give me the correct answer and give me the correct answer reasonably fast. And actually, I have a speed penalty for any program that takes like aeons upon aeons, 10 to the power of up arrow 3 years to give me the right answer.
Thinking of like Douglas Adams' Deep Mind.
Yeah.
Wouldn't it be basically the length of the program is a function? Well, the other way around. The speed is the function of the length, because at least in a universal Turing machine, you can only execute one instruction at a time. So the more instructions you have, the longer it'll take to run.
So are you familiar with the Busy Beaver number?
It's been a long time, but vaguely, yes.
So Busy Beaver is the number that the amount of steps that a universal Turing machine of length n can take at most. So the longest running machine that terminates of a given complexity class. And those are really, 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 really big. They're usually like when people talk about fast growing sequences, the Busy Beaver number is among them. Where like for like I don't know. I know that I think we know Busy Beaver 3, but we like Busy Beaver 4 no longer fits on like our hard drives, and Busy Beaver 5 is like much, much larger than could ever be represented in the existing known universe. I might be totally wrong here by many orders of magnitudes. It's very easy to be off by many orders of magnitudes here. But
please tell me why it's called Busy Beaver, if you know.
I don't actually know. I think it just I just imagine it as like, I don't know. I just have my headcanon, which is just that it's like I associate it with a small beaver that does a lot of work for a really long time, and it has a somewhat cartoony aesthetic, and it gets really exhausted after doing this for aeons and aeons. But I do not know whether that was the headcanon that people had when naming that.
When I look at Wikipedia, it goes for, I think there is a bunch of different ways you can set up the problem, but for the one where we have, for one of them with a 2 symbol, with a 2-state Turing machine, it can go for 6. For a 3-state, it can go for 21. For a 4-state, it can go for 107. For a 5-state, it can go for 47,176,870. For a 6-state, it goes for 7.4 times 10 to the power of 36,534. And then the 7-state goes, the 7-state goes for 10 to the 10 to the 10 to the 10 to the 18,705,353. And then at which point Wikipedia gives up. Can I say a random silly thing about the speed prior? Daniel Phelan, who is surprisingly now a housemate of mine. Well, I guess you maybe shouldn't be surprised. It's only of the last month. When I was at Oxford doing my undergrad in my first year, he came and he was looking for a place to stay, and I gave him a space in my room for free for like a month while he was visiting FHI. And he had a poster created and mailed to him in one of those like tubes, for a presentation, because he'd just done some work on the speed prior. And I think it arrived a couple of months ago. He just never arrived to him, and it's been 4 years. And then I recently got an email saying some posters arrived for you. Wow. So anyway, his paper on the speed prior was the slowest piece of mail that he has ever received.
Order it from?
I do not. I guess
like overseas, or to just get
maybe we should make updates about academia's speed or something.
So I have a question about this. I didn't find it controversial that laws of physics are easier to model on a computer than a human mind, and so I found that part relatively I skimmed past it. I was had a much harder time figuring out the last part of this post, which seems to be the opposite for you guys maybe can help me with it. It says near the end here that if someone says the lady down the street is a witch, she made the sequence come out 0101010101. Your accusation of witchcraft wouldn't let you shorten the rest of the message. You would still have to describe in full detail the data that the witchery caused. So even after you say witch, since you still have to describe the detail and full data, you have not compressed the total length of the message describing your observations by transmitting the message about witchcraft. You've simply added a useless prologue, increasing the total length. The real sneakiness was concealed in the word it. A witch did it. A witch did what? My question is, like, what does this mean exactly? Why is the compression of the total length important?
So I like going back to so we had a question of like, okay, I show you 3 images and you're trying to derive what the laws of physics are. And there's like a question of, and he said this thing of like, okay, you need 27 bits of evidence in order to like hone it down from a set of 100 million candidates. But what does it mean for an image to have 27 bits of evidence? It like obviously has many more. Like an image, like usually if it's like 1000 by 1000, will have like at least 100. Well, I know at least 1 million and probably at least 3 million because of like color information and various stuff like this, and probably also gradients and stuff like this. So the way I would imagine it is like when you look at the first 10 pixels of the image, how good are you at like how much better are you at predicting like the rest of the image, or more concretely like the world, like the laws of physics that you're trying to predict? And you can check. And that then, after looking at the first 10 bits, you can ask yourself, what information content did that have? How many hypotheses did those rule out? So similar for the witch one, you can look at the first 4 words and say, the lady down the street is a witch, she did it. And you can ask yourself, okay, after I heard those sentences, how good am I as a perfect Bayesian predictor at determining what the correct sequence is that like I'm trying to predict? And you hear those words and you're like, well, none.
Yeah,
I do not actually know. This has given me indeed 0 information about it. But if you change it and say the sequence was X, the lady down the street is a witch, she did it, and you ask yourself, okay, I first read the first 10 characters of the sentence. How good am I at predicting the sequence? And you're like, well, I have the sequence. That's it. I'm there. And then I give you more words, and you're like, well, okay, that clearly means that those words must be duplicates. They can't give me more information about the hypothesis earlier.
And if someone gave you just the sequence, you couldn't derive the lady down the street is a witch and she did it from that sequence.
Yeah. Even though that's not a necessary requirement, you might have the parts of your hypothesis don't necessarily need to be like correlated to each other. You could, but that's also like, I do think that if it is usually the case that for good explanations, part of them will allow you to explain other parts of the explanations. But I think that has more to do with explanations than perfect Bayesian predictiveness.
I think that's if I can maybe speak a little bit more practically to my experience or something. I think often a good explanation helps me. Often I think what I implicitly mean by a good explanation is something I can think about. I can use to think about a phenomenon without using up all of my working memory slots or something. If you this is a very human answer or something, but I can imagine like trying to get through a maze, and you could be like, you need to go left, left, right, 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 left, left, right. And I'm like, okay, I'm not thinking about anything else for the next 10 minutes while I follow those sequence of instructions. But then if you give me just always, use the left-hand rule, and you'll be able to like get out, which admittedly I think would be left, left, left. I'm not quite sure what it looks like, but I think that could like help me think of it in a much simpler way, whilst then being able to like think about other things at the same time.
I like that example.
Yeah, I guess. Thanks. I guess it's not a. Sorry, go for it.
No, I was just saying I might steal that example at some point.
Yeah, I think often good math research often looks like this, where they're like, oh yeah, we had this real complex model, but I've just like turned it into a like. I think when like first time you try and understand something in linear algebra or something, you like if I wrote it down in words or something, it would take me pages and pages and pages. And then you can just get it down to a point when if you have the right concepts, you just write like 3 lines or something, and you're like, oh yeah, I roughly get how the system works, and I can like manipulate these sort of symbols and these sorts of ideas with some others. I don't know, Ollie, do you have a better practical example? I feel like mine were either too abstract or...
It kind of explains the programming language thing too.
Yeah.
Where if you were to like write out in English, what this program was doing, or go levels down deeper if you're using Python. Like, yeah,
I agree.
I like starting to understand bits of it, although I still feel like there's stuff going over my head. But I'm glad that we had you guys on for these sequences.
Great.
Oh yeah.
I sent a text the other day that was just like, Occam's razor one is hired help. And it's like, oh, how could it be? I remember reading this and I opened it and I was just like, oh yeah, that one. I got nothing.
I feel like I sort of missed the point on this post because I have I think a good working intuitive version of Occam's razor, which is just like, I mean, if I give you an explanation for how the engine of my car works, and then someone else gave you the description of how the engine for my car works, and it was the same, except they said, and also little invisible fairies push the pistons in addition to the combusting gasoline. Like, Occam's razor would tell me, no, I'm going to take the one without the fairies because it has additional stuff on top of it that I don't need to explain this. And that even leaves aside the point that the fairy thing is really complicated, right?
Yeah, and I think there's another the kind of close by intuition is it just didn't even help me think about the thing. Dread the fairies. Never mind that I know that fairies are kind of magical. It just didn't. I already understood the engine and I already understood how to interact with it fully, or as well as I could. And you didn't help me by adding this extra thing to what I had to think about.
Yeah, but I think the key thing that I think this post does is it gives you it allows you to handle the situations where, well, but it's not impossible that they are fairies. Not literally absolutely impossible, but now you have to answer the question of, well, how impossible? And that's actually a really hard question that philosophy for in some argument, some could argue still not, but philosophy hadn't had an answer for thousands of years. We post Occam's razor, and we were basically well, the simplest one seems like the best one, but we didn't have the language of probability theory, so we couldn't tell you how much is the simplest one the better one. And the thing that he says in this post is, well, he is very concretely, if the thing adds this many bits of information, then it's in a larger complexity class, and therefore each additional bit of information must cut the probability that you assign to the hypothesis into 2. And it's a very precise answer, and that's very nice. And because fairies is a very complicated additional piece of data that makes the probability much, much, much lower. But if somebody were to give you a very slightly different explanation of an engine that maybe only is 1 or 2 bits longer, then you still have to assign substantial probability mass to that being right if it fits all the facts as well.
Okay, yeah, fair enough. I like that because you're right. I think I chose a too out there example of the fairies, but I could imagine
it's really satisfying to combine those two things. Where, I think of great explanations as usually being 2 separate phenomena, and now we have this thing where, I have this example that makes it so, if I posit a fairy thing, it seems like that sounds really dumb. But if I posit a thing where somebody gives a separate explanation that's just a bit more complicated, it doesn't sound that dumb. And now we have a single formalism that explains why the slightly different explanation still has some probability mass, whereas the fairies has basically no probability mass. Because we kind of know that there's an exponential relationship between the number of additional bits and the probability penalty it needs to get. And that's a really powerful intuition that I really like, because it takes these kind of 2 phenomena that didn't exactly know how they were related and combines them into one really elegant explanation.
I love it. Yeah, no, that's a really nice way of putting it.
Yay.
I was going to segue us straight into. That's kind of for me, Occam's razor 2.0. Speaking of 2.0s, let's talk about LessWrong 2.0. But we've got to say,
been at this game a long time.
We do have to quickly say what post we're reading next time, though.
Exactly. That's why it wasn't a good time to drop it. We've got to say what we're reading next.
Real quick, did anyone have last words before we move on?
Nah, I'm good.
Okay, then for next time, the post we're going to be reading is How to Convince Me That 2 + 2 = 3. Ooh. And the bottom line.